बिस्मिल्लाहिर्रहमानिर्रहीम। अस्सलाम वालेकुम स्टूडेंट आज हम डिस्कस करेंगे द डिराइवेशन ऑफ मोमेंट ऑफ इनर्शिया ऑफ ए यूनिफॉर्म होलो स्फीयर अबाउट ए डायमीटर। ये हमारे पास एक होलो स्फीयर है और इसकी हम रोटेशनल इनर्शिया मालूम करते हैं विद दिस एक्सिस विच passes through the center of the sphere. So the rotational inertia of this sphere with respect to this central axis is 2 over 3 mr square. Now, before the derivation of rotational inertia of the hollow sphere, let's consider this one. This is a hollow sphere which radius is OA or R. Now, rotate this OA around this x-axis, so a circle will be covered and the radius of this circle will be r sin theta. अगर इस डायग्राम को हम यहाँ पर ड्रा करें, दिस इज आवर सेंटर O, दिस इज A, यहाँ से हमने यहाँ पर एक परपेंडिकुलर को ड्रा किया, सो दिस इज R, सो दिस साइड बिकम r sin theta. So this circle which rotate around the OX axis having radius r sin theta. Now move this point from A to this one. So again, this is our radius r and this is also radius r and this is the length cover from A to this point B, and the angle subtended from A to B is d theta. So by a well-known radiation is equal to r theta, the length of this from A to B of this arc is rd theta. Now अगर हम इस B पॉइंट से एक सर्कल को रोटेट करें अराउंड the OX, so a ring will be produced, that is this one. The length of this ring is rd theta, this one. The radius of this ring is r sin theta, and the circumference of this ring or periphery of this ring is 2 pi r sin theta, because we know that the circumference is 2 pi r, but here for this ring the radius is r sin theta, so the circumference of the ring is 2 pi r sin theta. Now area of the ring will be what? So area of the ring defined as periphery या circumference multiplied by thickness of the ring. So periphery or circumference of the ring is 2 pi r sin theta and thickness of the ring is r d theta. So this is the area of the ring, that is 2 pi r sin theta into r d theta. Now mass of the ring, इस रिंग का मास कितना होगा, जो कि हमारे पास एक होलो स्फीयर का एक पार्ट है. तो mass of the ring defined as rho is multiplied by area of the ring. Rho is what? Rho is the surface mass density of the sphere, which is m over 4 pi r square. So the mass of the ring is m over 4 pi r square multiplied by area of the ring. So by simplify this, we obtain m over 2 sin theta d theta. This is mass of the ring. Now derivation of moment of inertia for a hollow sphere, that is I equal to 2 over 3 mr square. Let's consider a hollow sphere of mass capital M and radius r. O its center and OX is the axis of rotation. Let's consider a radius O equal to r of the sphere at an angle theta with the axis OX and rotate this radius about OX. The point A traces a circle on the sphere. Now change theta to theta plus d theta and get another circle of somewhat larger radius on the sphere. The part of the sphere between these two circles shown in the figure form a ring of radius r sin theta. The width of this ring is RD theta and its circumference is 2 pi r sin theta. इसको देखिए हमारे पास एक होलो स्फीयर है और इसका रेडियस है हमारे पास OA या इक्वल टू R. अगर इस पॉइंट को हम रोटेट करें अराउंड दिस OX, so a circle will be covered which radius is R sin theta. Now if we rotate if we move from A to point B, then the angle cover is d theta, and this length of arc from A to B is RD theta. Correct? So if we rotate this point B around this OX, so a ring will be produced. A ring will be produced. The thickness of the ring is RD theta and radius of this ring is R sin theta and circumference of this ring is 2 pi r sin theta. As area of the ring is 2 pi r sin theta into d theta, ये हमारे पास जो है रिंग है और इसकी एरिया की इक्वेशन है 2 pi r sin theta into r d theta. And mass per unit area of the sphere rho s is m over 4 pi r square. M over 4 pi r square is known as mass per unit area, where m is total mass of the sphere and r is the radius of the hollow sphere. The mass of the ring dm is equal to rho s multiplied by area of the ring, where rho s is this one, m over 4 pi r square, and area of the ring is 2 pi r sin theta into r d theta. So r into r square cancel to r square, pi to pi, and 2 to 4. So this become m over 2 sin theta d theta. This is mass of this ring. Now the moment of inertia of this elemental ring about OX is moment of inertia of this ring di equal to dm into r square, where dm is m over 2 sin theta d theta. This is mass of the ring, and r is what? Radius of the ring, which is r sin theta whole square. So di rotational inertia of small ring become m over 2 r square sin cube theta into d theta. But remember, the hollow sphere consists on various number of rings, so we integrate this expression for the whole sphere. The moment of inertia of the hollow sphere which consists on various rings, so integrate by equation. This equation को अगर हम integrate करें, so we obtain the rotational inertia for the whole hollow sphere. Now to obtain the rotational inertia for the whole hollow sphere, integrate the last expression, that is I equal to 0 to pi m over 2 r square into sin cube theta d theta. यहाँ पर थीटा की लिमिट हमने पुट की है फ्रॉम 0 टू पाई, बिकॉज वी नो दैट इन स्फेरिकल पोलर कोऑर्डिनेट द लिमिट ऑफ थीटा इज 0 to pi. So this expression can be written as mr square by 2 into 0 to pi 1 minus cos square theta sin theta d theta. We know that sin cube theta is sin square theta into sin theta. So sin square theta is also equal to 1 minus cos square theta into sin theta. Now multiply this sin theta to 1 and this sin theta to this one. So we obtain mr square by 2 0 to pi sin theta d theta minus 0 to pi cos square theta sin theta d theta. Or mr square by 2 by integration of sin theta is minus cos theta 0 to pi, and this can be written as plus 0 to pi cos square theta minus sin theta d theta. By this integration, using this integration, इसका डेरिवेटिव जो है यहाँ पर एग्जिस्ट करता है. सो इसका जो है इंटीग्रेशन बन जाएगा कास स्क्वायर थीटा इंटू माइनस साइन थीटा डी थीटा. इसका इंटीग्रेशन बन जाएगा प्लस कास क्यूब थीटा डिवाइड बाई 3. लेकिन ये प्लस जो है यहाँ से हम माइनस को कॉमन करेंगे. सो दिस माइनस विल बी इक्वल टू माइनस, और ये प्लस जो है माइनस में कन्वर्ट हो जाएगा. माइनस कास क्यूब थीटा बाई 3 0 टू पाई. नो पुटिंग अपर लिमिट माइनस लोअर लिमिट, वी obtained by putting upper limit lower limit, this is pi 180. So minus mr square by 2 cos 180 minus cos 0 minus 1 over 3 upper limit cos 180 whole cube minus cos 0. And cos 180 is minus 1 and cos 0 is minus 1. So minus 1 over 3 and cos 180 minus 1 or minus 1 का हम cube ले लें, so this become minus 1 and minus as it is and cos 0 is 1. So this become minus mr square by 2 into minus 2 plus 2 by 3 or minus mr square by 2 minus 6 plus 2 by 3 or 4 over 6 mr square equal to 2 over 3. So this is the rotational inertia for a hollow sphere. Thank you.